crunchy pickle spear that snaps between your teeth began its life racing against the summer clock, growing so fast that a cucumber can stretch half its own length in a single night? Have you ever wondered how fields bursting with hundreds of millions of cucumbers every season are magically transformed into tangy, garlic dill pickles that line supermarket shelves from Bangkok to Boston? And how, somewhere in that journey, armies of microbes team up with gleaming stainless steel fermenters to lock in flavors our grandparents once coaxed from wooden barrels? Slip on a pair of mud-proof boots and follow that green gherkin from vine to brine, through the biggest pickle operation on the planet, where scale meets science in a symphony of crunch. Long before salt or vinegar ever touches a cucumber, the seed must hit warm soil tucked beneath plastic mulch that functions like a solar blanket. In the American Southeast, Midwest, and California's Central Valley, or halfway across the world, in India's Gujarat Plain and China's Shandong Province, planters fitted with GPS glide down perfectly parallel beds in April and May. Each tiny seed, no larger than a grain of rice, drops into loosened earth precisely 2 inches deep and 9 inches apart. Overhead, irrigation pivots whisper arcs of water, so droplets fall like mist rather than bullets. Seedlings bruise easily during their first delicate week. Meanwhile, honeybees and bumblebees do reconnaissance runs, scouting flowers that will open a mere 35 days later. Farmers often lease portable hives, knowing that without vigorous pollination, a blossom will shrivel, leaving behind a stubby, bitter nub instead of the shapely cuke destined for your sandwich. Cucumbers sprint through their adolescence. Inside the spongy interior, cells divide at breakneck speed, pushing the outer skin until the fruit feels like a tiny, chilled water balloon. If the mercury hovers in the ideal 26 to 30 degrees Celsius sweet spot, a pickle class variety achieves picking size, about the length of your middle finger, in just 8 days after pollination. Because they grow this quickly, farmers patrol rows each dawn with smartphone apps tied to satellite heat maps, flagging sectors that must be harvested in the next 24 hours, or risk overshooting the diameter spec that buyers demand. A cuke allowed to bulk up even 1 extra day might end up in relish or cattle feed, rather than the premium spear market. When harvest begins, the fields resemble synchronized ballets of green-painted machinery. Hand-picking once ruled, but today, self-propelled pickers dominate large acreage. Imagine a horizontal Ferris wheel outfitted with rubber paddles. As vines pass beneath the machine, rotating drums whisk cucumbers off their stems but leave leaves and blossoms behind. The crop drops onto conveyor belts, then into cushioned bins mounted alongside the cab. Built-in fans blow dusty fuzz away, and cameras scan coloration, immediately ejecting yellowed outliers. Each harvester can gather upward of 25 tons per hour. Still, smaller boutique farms stick to hand crews because the human fingertip remains unrivaled at sensing the exact firmness that signals peak crunch potential. Workers slip cucumbers into canvas slings on their hips, then dump loads into crates that head straight for the refrigerated wagon waiting at the field's edge. Within 90 minutes, those wagons back up to the receiving bay of an industrial plant that hums louder than a rock concert. Time matters. Room temperature cukes respire sugar into CO2 and soften quickly, so an evaporative pre-cool tunnel blasts 2-degree air across every crate, chilling the fruit's core temperature from 30 to 10 degrees Celsius in under an hour. As the crates tip onto a stainless steel flume, water jets jostle out field debris, twig fragments, sand, the occasional hitchhiking grasshopper. High-pressure sprays scrub off the fruit's natural blossoms' ends, while rotating brushes de-spine any prickly varietals. A polished, still-wet cucumber now rolls beneath arrays of optical graters mounted with hyperspectral cameras. Each lens captures light far beyond the human spectrum, instantly reading chlorophyll density, sugar level, and even microbruises invisible to naked eyes. Software then commands diverter rods to sort by length and girth into separate lanes. The petite 1.5-inch gherkin lane, the 3-inch sandwich spear lane, and the hefty 5-inch salting cucumber lane. Conveyor belts feed these grades to different pickling tracks because, as any brine master will tell you, a one-size-fits-all soak inevitably yields uneven crunch. For traditional fermented pickles, the kind that fizz gently when you pop the lid, cucumbers dump into 35,000-gallon fiberglass-lined tanks sunk partly below ground. Brine mixers chug like cement trucks nearby, dissolving kiln-dried salt into well water until hydrometers bob at precisely 5.5% salinity. Workers wheel tall mesh baskets of garlic cloves, furlongs of fresh dill, mustard seeds, peppercorns, and crushed coriander seeds to catwalks above each tank, broadcasting the aromatics in swirling torrents. Finally, brine gurgles in, submerging cucumbers beneath floating plastic lids weighted with inflatable bladders that prevent air pockets. Over the next 3 weeks, lactic acid bacteria present on cucumber skins awaken, feasting on vegetable sugars. The brine's pH plummets, lactic acid builds, and the interior flesh transforms from verdant, watery melon to firm, ivory green pickle. In smaller craft fermentaries, wooden oak barrels breathe micro-oxygen that deepens tanginess, but megaplants rely on rigorous anaerobic control because stray oxygen invites spoilage yeasts. For quick process or refrigerator pickles, the crisp coins you love on a burger, time collapses from weeks to mere hours with hot vinegar brine. A heat exchanger scalds white vinegar, water, salt, sugar, and spice oil emulsions to 82 degrees Celsius. The cucumbers load into rotary retort baskets, and steaming brine floods in, chasing bubbles from every blossom scar and seed cavity. After 5 minutes, vacuum pumps suck brine out while a chilled solution races back, drawing atmospheric pressure that forces brine into microscopic voids. As the jars exit, internal probe thermometers confirm a pasteurizing 72 degrees center, guaranteeing shelf stability without crushing texture. Whether fermented or vinegar cured, each batch faces the crunch test. A trained technician snips 5 pickles, stands them upright in a mechanical instrument called a texture analyzer, and watches a stainless probe drive down until the pickle snaps. The peak force appears as a spike on the graph. Anything below the spec of 1.5 kilograms, force signals mush. Sensors also evaluate bloom, the moment that probe first punctures the skin. The sharper the bloom, the snappier the first bite. Deficient lots might be diverted into relish grinders or diced pickle salads. Nothing goes to waste, but premium jar space is reserved for maximal crunch. Back on the line, thousands of gleaming jars gallop past filling nozzles so precisely timed they can dispense 24 ounces of brine in 0.4 seconds without foaming. Automatic vision systems count pickle halves by silhouette and trigger puffers that add or subtract a spear to hit the label promise, whether that's 7 stackers or 15 baby dills. Lids coated with plastisol ringers screw on. Then the jars invert over superheated steam jets to sterilize the headspace. A final water cascade cools glass from 85 to 35 degrees before inkjets print date codes for traceability. For the refrigerated line, where true fermentation would still be bubbling, pickle pouches rather than glass jars dominate. Flexible multi-layer films are fed into a form-fill seal carousel. Pickles plop into gusseted bags. A nitrogen gas puff inflates the pouch to protect fragile spears, and ultrasonically welded seams seal in probiotic goodness. Because these products keep their living culture, they sprint straight to cold storage, still actively generating tang. Forklifts whisk pallets into a 2-degree Celsius room tall enough to swallow a 5-story building, each aisle patrolled by driverless shuttles that slide pallets onto racks 14 deep, guided by QR codes embedded in concrete. In a world cracking down on plastic, the industry invests heavily in sustainability. Brine left over from each fermentation cycle contains calcium salts and lactic acid, liquid gold for farmers of silage corn who use it as both fertilizer and probiotic inoculant. Plants evaporate excess water using waste heat from their boiler stacks, concentrating the liquor to cut trucking volume. Glass cullet from misprinted jars flows to nearby glassworks where temperatures soar above 1,450 degrees Celsius, easily purging residual salt. Even cull cucumbers culled for odd curves are shredded into juice, fermented to ethanol, and blended into boiler fuel that powers the pickling plant itself. Yet technology never fully replaces taste memories, and the plant's R&D team knows it. Every quarter, they invite a half-dozen grandmothers of assorted cultural backgrounds: Polish, Korean, Indian, Jewish, Filipino, Southern American, to bring their family pickle recipe. In a sensory theater lined with micro-kitchen stations, lab scientists replicate each recipe at pilot scale, deconstructing the ratios of salt to acid, spice to sweetness, crunch to chew. Many a blockbuster flavor profile: sriracha dill, bread and butter chip with smoked paprika, kimchi-style firecrackers, emerged from these collaborative pickle summits. It's a respectful nod to the culinary heritage that industrialization borrowed from. When truck doors finally swing open at supermarkets thousands of miles away, those pickles still hum with microbial life or sparkle with vinegar brightness. A shopper plucks a jar, admiring how spears align perfectly like soldiers in parade rest. She hears glass clink, imagines the midday sandwich she'll build, and feels only anticipation. not the thrum of conveyor belts, the hiss of steam retorts, the susurration of bees pollinating blossoms 90 days earlier. Her crunch, however, is the final punctuation to a colossal choreography that began in sun-drenched soil and marched through metals, microbes, mathematics, and age-old tradition. So next time you fork a pickle onto your plate, let the snap echo for just a heartbeat longer. Inside that sound lives an epic story of growth, precision, and unending quest for the perfect tang.
Are you fascinated by the rich, silky sweetness of bulk condensed milk and wonder how it's produced on a large industrial scale? You're not alone. How is condensed milk made? Has become a top trending query, and for good reason. Condensed milk is a cornerstone of countless milk-based recipes, from pastries and desserts to coffee drinks. In this in-depth look, we'll explore each stage of milk processing, from the farm all the way to the final packaged product in tanker trucks or large drums. Along the way, we'll highlight food safety measures, modern technology, and global market trends, key topics frequently searched on Google and YouTube. From farm to factory, the milk supply chain. Everything begins on dairy farms where cows produce fresh milk that's collected in stainless steel receptacles. The milk is then transferred via insulated tanker trucks to processing plants, a segment often called the milk supply chain, a phrase trending on Google and YouTube. Upon arrival, the raw milk goes through strict food safety checks, including tests for bacterial count, antibiotic residues, and overall milk quality. If it passes inspection, the milk is pumped into refrigerated silos to maintain freshness and safety. The entire milk supply chain is governed by regulations designed to keep the product uncontaminated from farm to factory. This scrupulous attention to detail ensures that when the milk is converted into condensed milk, it meets the high standards for taste, consistency, and shelf life. Filtering and clarification. Preparing for perfection. Next, the raw milk is sent through advanced filters or clarifiers to eliminate dirt, debris, and other impurities. Milk filtration and milk standardization are crucial steps, trending topics among those curious about how dairy producers achieve consistency and clarity. These machines often utilize centrifugation, spinning the milk at high speeds to separate out unwanted solids. At this point, the milk is also standardized for protein and fat levels, ensuring it meets precise specifications. This consistency underpins a uniform final product. Once filtered, the milk is transferred to storage tanks and closely monitored for temperature, pH, and microbial activity. Pasteurization, ensuring food safety. Before the transformation into condensed milk can begin, the milk must be pasteurized. This step, often linked with popular searches like milk pasteurization or milk safety, involves heating the milk to temperatures typically between 72 degrees Celsius and 80 degrees Celsius, 161 degrees Fahrenheit to 176 degrees Fahrenheit, for a set duration to kill harmful bacteria. Some factories use high-temperature short-time HTST pasteurization. Others opt for ultra-high-temperature UHT methods. Pasteurization not only addresses food safety concerns, but also preserves essential nutrients. Once completed, the milk is rapidly cooled. From here, it's ready for the heart of the process, the transformation into condensed milk through evaporation. Evaporation, concentrating the milk. The distinct thickness of condensed milk is achieved by removing roughly half of its water content. Industrial operations rely on specialized milk evaporation systems, such as falling film or multiple effect evaporators. Evaporation under vacuum allows water to boil at lower temperatures, preserving flavor and nutrients. As the milk descends through tall columns in thin layers, it loses water at each stage. The steam generated is recycled to minimize energy consumption, reflecting the industry's increasing focus on milk sustainability. When the process finishes, the resulting liquid is now evaporated milk, thick, creamy, and primed for further steps. Adding sugar, the sweet factor. What separates evaporated milk from sweetened condensed milk? Sugar. Large industrial mixers blend sugar into the concentrate, typically at 40% to 45% of the total mixture. This step is integral not only for taste, but also for shelf life. Sugar acts as a natural preservative by reducing the available water that bacteria need to thrive. Sometimes referred to in discussions about milk sweeteners, this blending process is carefully calibrated so the sugar dissolves fully, preventing graininess. Factories must also pay attention to sugar particle size, mixing speed, and temperature to ensure a seamless blend. The end product is a luxuriously sweet base that becomes the condensed milk found in bulk containers worldwide. Homogenization, creating a velvety texture. After sweetening, many producers opt to homogenize the mixture. During milk homogenization, the liquid is forced through extremely narrow channels under high pressure. This breaks down fat globules so they remain evenly suspended, preventing separation or a layer of cream forming on top. Homogenization yields a consistent, silky texture that's become a hallmark of premium condensed milk. Because milk homogenization has been trending in online searches, it's clear that consumers and professionals alike value the smooth mouthfeel it provides, a key attribute for recipes ranging from fudge to latte toppings. Cooling and controlling crystallization. Once the sweetened, homogenized milk is ready, it must be cooled carefully to manage sugar crystallization. If the product cools too fast, large crystals can form, creating a grainy mouthfeel. Modern factories use sophisticated cooling tunnels or plate heat exchangers to lower the temperature slowly and evenly. Automation systems monitor temperature drops in real time, ensuring consistent crystallization and maintaining top-notch milk quality. This step is critical in bulk production, as even a small error in cooling can affect massive quantities of finished product. Temperature-controlled processes help guarantee the condensed milk stays smooth, stable, and ready for long-term storage. Bulk packaging. Drums, totes, and tanker trucks. Rather than the familiar small cans on grocery shelves, bulk condensed milk is typically packed in large drums, intermediate bulk containers, IBCs, or entire tanker trucks. The choice depends on the volume and the final destination, be it a giant confectionery, a chain of bakeries, or even international export markets. Drums can hold up to about 200 liters, 53 gallons. IBCs, totes, often store up to 1,000 liters, 264 gallons. Tanker trucks transport tens of thousands of liters in temperature-controlled conditions. Bulk packaging must adhere to food safety regulations, including sealing and labeling for traceability. Topics like milk canning and milk distribution remain popular in online searches, especially for professionals needing large volumes for commercial use. Quality control, safety, and consistency. From the moment raw milk arrives to when the final product leaves, food safety is paramount. Factories conduct stringent tests at each phase, measuring attributes like sugar concentration, total solids, pH, and microbial counts. Many use advanced on-site labs for continuous monitoring, aligning with guidelines such as Good Manufacturing Practices, GMP, and Hazard Analysis and Critical Control Points, ACCP. Because consumers and businesses trust condensed milk as an ingredient, it must meet strict criteria before distribution. Milk quality checks ensure there are no off flavors, unwanted odors, or bacterial contamination. By maintaining high standards, plants protect their reputations and comply with local and international regulations. Storage and distribution, keeping it cool. Once the product has passed final inspections, it is stored in refrigerated warehouses or loaded directly onto trucks designed to keep the product within a safe temperature range. Proper milk distribution is a trending topic as global supply chains grow more complex, especially when shipping across multiple regions. Large food and beverage manufacturers depend on reliable logistics to integrate condensed milk into products like cakes, candies, ice cream, and iconic confections such as dulce de leche. Because sweetened condensed milk is relatively shelf-stable thanks to its high sugar content, companies can keep adequate inventories without worrying about rapid spoilage. This stability is part of what makes condensed milk such a powerhouse ingredient in industrial food production. Innovations in condensed milk production. Dairy processing continues to evolve with cutting-edge technologies, leading to more sustainable, efficient, and high-quality products. Some factories are experimenting with alternative sweeteners like stevia or monk fruit to reduce sugar levels without compromising flavor. Others use smart factory principles, employing sensors, automated control systems, and data analytics to optimize energy usage and reduce waste. Robotics increasingly play a role in packaging and palletizing bulk containers, streamlining processes, and minimizing manual labor. As milk sustainability gains momentum, manufacturers invest in energy-efficient evaporators and eco-friendly packaging solutions to lower their carbon footprints. Consumers can expect more innovations aimed at balancing taste, cost, and environmental responsibility. Market demand and global reach. The global demand for sweetened condensed milk continues to climb, largely driven by a surge in milk consumption and milk-based recipes worldwide. In regions like Asia, Latin America, and parts of Africa, condensed milk is a favorite for sweetening teas, coffees, and desserts. Meanwhile, Western markets incorporate it into baked goods and candies. As milk consumption remains a hot topic online, international food giants cater to regional preferences by adjusting thickness, sweetness levels, and flavor nuances. Some cultures enjoy a more caramelized profile, while others prefer a lighter sweetness. No matter the variant, bulk condensed milk remains an indispensable ingredient, fueling everything from local delicacies to large-scale commercial confections. Use cases for bulk condensed milk. Why do producers and food giants purchase condensed milk in bulk? The short answer: scale. Bakeries and confectioners require massive quantities to satisfy the volume demanded by pastry shops, dessert manufacturers, and beverage creators. Chains serving popular drinks like caramel frappes, bubble tea, or sweet lattes can use tanker loads of condensed milk daily. In confections, condensed milk's high sugar content and stable texture make it indispensable for fudge, toffee, caramel, and other treats that rely on consistent moisture levels. High sugar concentration also naturally prolongs shelf life, reducing the likelihood of spoilage. This reliability and versatility explain why countless businesses rely on bulk condensed milk as a key product component. Challenges and considerations. Despite its advantages, bulk condensed milk production poses unique challenges. The high sugar concentration requires precise temperature control to avoid scorching. Factories must operate in pristine, hygienic conditions to meet food safety standards and prevent contamination. Even transportation in tanker trucks demands careful handling, as temperature fluctuations or improper sealing can degrade product quality. Cost can also be a factor. The prices of raw milk and sugar vary with market conditions, placing stress on profit margins. Many companies address environmental pressures by investing in milk sustainability measures such as water conservation, reduced energy consumption, and greener packaging. Adopting sustainable approaches not only helps the environment, but also appeals to increasingly eco-conscious consumers. Final thoughts: the sweet reward. From the dairy farm to the factory floor, bulk condensed milk production is a testament to modern science, engineering, and commitment to food safety. Every step: milk filtration, standardization, pasteurization, evaporation, sugar addition, homogenization, and careful cooling ensures a thick, sweet result that's uniform in quality. Packaging in drums, totes, or tanker trucks follows equally rigorous guidelines. Whether used in a local bakery's cakes or a multinational brand's confections, condensed milk remains a cornerstone of milk-based recipes around the world. With advancements in milk processing technology, improved sustainability measures, and robust global distribution networks, the future of bulk condensed milk looks brighter and more innovative than ever. When you think of comfort food, few things come close to the irresistible appeal of KFC's crispy tenders. But have you ever paused to consider what goes into crafting these golden bites of perfection? It's not just about frying chicken. It's about a journey that combines cutting-edge technology, centuries-old culinary traditions, and an unwavering commitment to quality. Behind every crispy tender is a story, one that begins in the serene countryside and ends on your plate, delivering a burst of flavor with every bite. Today, we're pulling back the curtain to show you the meticulous process that turns fresh farm ingredients into one of the world's most beloved snacks. Grab a seat and get ready to savor every detail of this incredible journey. Our story begins in the lush, expansive fields of the United States, where carefully managed poultry farms lay the foundation for KFC's world-renowned crispy tenders. These farms are not your ordinary operations. They are meticulously designed to prioritize the health and well-being of the chickens. Spacious, state-of-the-art barns provide the birds with ample room to roam freely, promoting natural behaviors and reducing stress. This freedom to move and engage in instinctive activities plays a vital role in raising healthy, robust chickens, a cornerstone of KFC's commitment to quality. The farms employ advanced technology to ensure optimal living conditions. For instance, automatic dispensers deliver fresh, clean water around the clock, ensuring the chickens are always hydrated and in peak condition. The feed, too, is carefully formulated to meet the nutritional needs of the birds, enhancing their growth and overall health. It's not just about raising chickens, it's about creating an environment where they thrive. This humane and nurturing approach is pivotal in producing chickens that meet the stringent standards required for KFC's crispy tenders. After all, happy chickens result in better tasting tenders, and that's a win-win for everyone. Once the chickens are fully grown and ready for the next phase, the collection process begins. This stage is a marvel of modern technology designed to prioritize the welfare of the birds. Advanced collection machines, resembling large yet gentle vacuum systems, carefully gather the chickens without causing harm. These machines are engineered to minimize stress, ensuring the birds remain calm throughout the process. Unlike traditional methods, which could be stressful or even harmful, these innovative machines represent a leap forward in humane farming practices. The chickens are gently placed into specially designed crates that are both secure and well ventilated. These crates are crucial for maintaining a calm and comfortable environment during transportation. By minimizing stress and ensuring the chickens are handled with care, KFC takes another step in preserving the quality and integrity of its product. The journey from the farm to the processing plant is smooth and carefully managed, setting the stage for the next exciting chapter in the tender's creation. At the processing plant, the chicken's journey continues with an unwavering commitment to quality and animal welfare. The unloading process is a seamless blend of human expertise and automation. Skilled workers and advanced systems work together to ensure that every step is efficient, humane, and designed to uphold the highest standards of care. Once unloaded, the chickens are placed on conveyor belts that transport them through the initial stages of processing. This is where the magic of modern food technology comes into play. The first step involves humanely stunning the chickens using advanced methods that are quick, painless, and in line with industry best practices. This critical process ensures the chickens are unconscious before moving on to the subsequent stages, reflecting a deep respect for animal welfare. The processing plant operates with a precision that is nothing short of extraordinary. Every machine and worker is focused on maintaining the quality, safety, and integrity of the chickens. It's a highly orchestrated operation where technology and craftsmanship converge to create a product that meets KFC's exacting standards. With the chickens now ready for further processing, the preparation stage begins. This involves a series of meticulous steps designed to ensure the meat is clean, tender, and of the highest quality. The first task is feather removal, a process handled by specialized machines that work quickly and efficiently. These machines use gentle yet effective methods to remove feathers, leaving the chickens ready for the next step. The cleaning process is equally thorough, Internal sections are carefully removed, and the chickens are subjected to high-pressure water jets to wash away any impurities. This step is crucial for maintaining hygiene and preparing the chickens for cutting and further processing. Every bird is inspected to ensure it meets the stringent cleanliness standards required for KFC products. Once cleaned, the chickens are cut into various parts with remarkable precision. The prized breast pieces, which will eventually become KFC's crispy tenders, are separated from the rest of the chicken. These cuts are handled with the utmost care to preserve their tenderness and juiciness. It's a process that combines technology with a deep understanding of culinary science, setting the stage for the transformation into the iconic crispy tenders. Before the tender breast pieces take on their final form, they undergo a unique preparation process that ensures maximum juiciness. The pieces are placed into drum rollers, specialized machines designed to gently tumble the chicken and lock in moisture. This step is pivotal in creating the signature juiciness that KFC's crispy tenders are famous for. The drum rolling process is not just about moisture retention, it's also about enhancing the texture and flavor of the meat. As the chicken pieces are tumbled, they are evenly coated with a light marinade that penetrates deep into the meat, infusing it with flavor. This ensures that every bite is bursting with taste, making the tenders as satisfying as they are delicious. After tumbling, the chicken pieces undergo a rigorous inspection by skilled workers. Each piece is examined to ensure it meets KFC's high standards of quality. Only the best pieces move on to the next stage, where they will be transformed into the crispy, golden tenders that have become a global favorite. The transformation from tender chicken breast to crispy delight begins with the coating process. The chicken pieces are evenly coated with a special flour mixture that is key to KFC's unique flavor and crunch. This isn't just any flour. It's a proprietary blend of ingredients that has been perfected over decades to create the perfect balance of flavor and texture. The coating process is a marvel of precision and consistency. Each piece of chicken is carefully dredged in the flour mixture, ensuring it is completely and evenly covered. Vibrating belts then shake off any excess flour, creating a uniform coating that is crucial for achieving that iconic crispy texture. This stage is where the chicken begins to take on its characteristic look and feel. The evenly coated pieces are now ready for the partial frying process, a critical step in creating the golden, crunchy exterior that makes KFC's tenders so irresistible. Partial frying is the secret to achieving the perfect balance of crispy and tender. The chicken pieces are fried just long enough to develop a golden brown crust while retaining their juicy interior. This step locks in the flavor and sets the stage for the final cooking process, which takes place in KFC kitchens worldwide. Once partially fried, the tenders are cooled and prepared for packaging. This cooling process is carefully controlled to ensure the quality and texture of the chicken are preserved. Each piece is handled with care to maintain its integrity and ensure it arrives at its destination in perfect condition. Quality assurance is at the heart of KFC's operations. Every step of the process, from the farm to the fryer, is designed to ensure the highest standards of safety, consistency, and taste. The tenders undergo rigorous inspections at multiple stages to verify that they meet KFC's exacting criteria. These inspections are not limited to the physical appearance of the tenders. Advanced testing methods are used to assess factors such as moisture content, texture, and flavor. This comprehensive approach ensures that every piece of chicken that leaves the factory is of the highest quality. Once the tenders pass all inspections, they are packed and shipped to KFC locations around the globe. This final step is a testament to KFC's commitment to delivering a consistent and delicious product to its customers. Each package is carefully sealed to preserve freshness and flavor, ensuring that the tenders arrive in perfect condition. The distribution process is a complex operation that relies on advanced logistics and cold chain technology. These systems ensure that the tenders remain fresh and ready for cooking, no matter where they are shipped. It's a global effort that brings the taste of KFC's crispy tenders to millions of people worldwide. At KFC, the journey of the crispy tenders reaches its climax. When you place your order, the tenders are fried to perfection, achieving that golden, crispy exterior and tender, juicy interior. The final cooking process is a precise art, ensuring that every piece is served hot, fresh, and delicious. The result is a culinary masterpiece that delights the senses. The crunch of the coating, the juiciness of the chicken, and the explosion of flavor with every bite make KFC's crispy tenders a true crowd pleaser. It's the perfect combination of taste, texture, and satisfaction, all brought together by a process that celebrates quality and innovation. And there you have it, the incredible journey of KFC's crispy tenders. From the serene farms to the state-of-the-art processing plants, every step is a testament to quality, care, and a passion for delivering the best.
Welcome to the heart of potato innovation, where the humble spud undergoes a remarkable transformation into creamy, delicious mashed potatoes in American factories. This process combines agricultural expertise, cutting-edge technology, and a passion for quality. Join us as we take an in-depth look at each step of this fascinating journey, showcasing how these beloved comfort foods are made on a grand scale. Hit that subscribe button and turn on notifications so you won't miss out on our deep dive into the fascinating journey from field to factory. Let's explore the magic behind every scoop of mashed potato. Field to factory, the journey begins on the sun-kissed fields of America, where high-quality potatoes are harvested by skilled farmers. These farmers understand that not all potatoes are created equal. They carefully select varieties known for their ideal texture and flavor. Popular choices include russets, which are high in starch and lend themselves well to mashing, and Yukon Golds, which bring a rich, buttery taste. After selecting the best potatoes, farmers harvest them using mechanized equipment that minimizes damage and maximizes efficiency. Once harvested, the potatoes are sorted and packaged for transport. This crucial first step establishes the foundation for the entire production process, as only the best potatoes will lead to the finest mashed products. Farmers often collaborate with processors to determine the necessary sizes and quality for optimal mashing, ensuring that their crops meet industry standards and consumer expectations. Transportation. After harvest, these carefully chosen potatoes are transported in bulk to processing facilities across the country. Logistics play a crucial role in this phase, as ensuring the freshness of the potatoes during transport is vital. Companies deploy large trucks equipped with climate control systems that prevent the potatoes from spoiling or becoming damaged due to temperature fluctuations. During transportation, the potatoes are protected from the elements, with careful loading and unloading procedures designed to prevent bruising. For many facilities, proximity to local potato farms helps to reduce the time from field to factory, allowing the freshest product possible to reach the processing plant. This attention to detail at every stage ensures that consumers will experience the highest quality when they eventually enjoy their mashed potatoes. Quality inspection. Upon arriving at the processing facility, the potatoes undergo rigorous quality inspections. This step is vital in eliminating any potatoes that may be damaged, rotten, or otherwise unfit for processing. Trained staff members or advanced machinery carefully evaluate the potatoes based on size, color, and overall appearance. The inspection process ensures that only the best potatoes make it into production, safeguarding the quality of the end product. Any potatoes that do not meet the necessary standards are sorted out for other uses, such as animal feed or composting. This strict adherence to quality control right from the beginning sets the tone for excellence in the final product. Washing and peeling. After quality inspection, the potatoes move to the washing station, where they are thoroughly cleaned to remove any dirt, stones, or impurities accumulated during harvesting and transport. This process involves high-pressure jets and scrubbing machines that efficiently scrub the potatoes clean. Once washed, the potatoes proceed to peeling, which is accomplished using specialized machinery designed to maximize efficiency. It is important that peeling is done without damaging the underlying flesh of the potato. Therefore, most facilities employ machines equipped with precision rollers that carefully peel away the skin while preserving the integrity of the potato. This step not only ensures a clean, smooth final product, but also helps maintain the quality of the potatoes, ensuring that no flavor is lost during the peeling process. Chopping and cooking. After peeling, the next step in the process is chopping. Potatoes are cut into uniform pieces to ensure even cooking. This uniformity is crucial because it allows all potato pieces to cook thoroughly at the same rate, resulting in a consistent texture when mashed. The chopped potatoes are then transferred to large steam kettles where they are cooked until tender. Cooking in steam kettles is advantageous because it retains more flavor and nutrients compared to traditional boiling methods. The use of steam also speeds up the cooking process, allowing for a higher volume of mashed potatoes to be produced in less time. Monitoring cooking times and temperatures is critical during this stage. Operators carefully regulate these factors to prevent overcooking, which can lead to breakage and a less desirable texture in the final product. Mashing process. Once cooked, the potatoes are ready for the mashing process. They are fed into high-capacity mashers that are capable of processing large volumes of potatoes quickly and efficiently. These machines utilize robust blades to break down the cooked potatoes until they reach a smooth, uniform consistency. The mashing stage is essential for bulk production as it allows for rapid processing while maintaining quality. The texture achieved during this process will greatly influence the satisfaction consumers derive from the final product. Facilities often feature adjustable settings on their mashers, allowing operators to customize the final texture, whether it be smooth or slightly chunky, according to customer preferences. Flavor enhancement. At this stage in the process, it's time to elevate the taste of the mashed potatoes. Facilities add various ingredients that enhance flavor and create the comforting taste consumers love. Butter and cream are common staples, contributing to the rich, velvety mouthfeel. In addition to these traditional ingredients, facilities can also incorporate seasonings such as salt, pepper, garlic powder, and other flavors to cater to specific consumer taste aids. Some factories even offer flavored varieties like garlic or cheddar mashed potatoes, further expanding the product's appeal. The flavor enhancement process occurs under strict regulations, ensuring that all added ingredients meet safety standards and contribute positively to the overall quality of the mashed potatoes. Cooling and packaging. Once the potatoes have been perfectly mashed and flavored, it's crucial to cool the mixture quickly to maintain quality. A rapid cooling process helps to prevent bacterial growth and preserves the flavor and texture of the mashed potatoes. The cooled mashed potatoes are then packaged into large containers or pouches, depending on retail and restaurant needs. This step is performed with extreme care to avoid any contamination and to confirm the consistency of the product. Many factories utilize automated bottling and sealing machinery, which helps in maintaining hygiene and reducing the risk of human error. Packaging is not only about functionality, it must also be visually appealing and informative, providing consumers with necessary details about the product, including ingredients, nutrition information, and storage instructions. Quality control measures. Throughout the entire production line, strict quality control measures are in place. From the moment the potatoes arrive at the facility to when the final product is packaged, numerous checks ensure each batch meets rigorous safety and taste standards. This multi-layered approach involves both human inspectors and automated systems where sensors monitor everything from moisture levels to consistency and texture. Regular sampling and testing are integral to this process, allowing for immediate action if any irregularities are detected. For producers, maintaining the standard of quality is essential, not only for consumer trust, but also for compliance with health regulations and industry guidelines. Storage solutions. Once packaged, the mashed potatoes are stored in climate-controlled warehouses. These storage facilities are designed to maintain optimal temperatures, ensuring that quality is preserved until the product makes its way to the market. Proper storage solutions are vital for extending shelf life and maintaining flavor. Before shipment, the inventory is regularly monitored to track expiration dates, ensuring that only the freshest products are sent out to retailers and food service providers. This meticulous attention to detail underscores the commitment to quality that permeates every step of the production process. Distribution. With everything in its rightful place, it's time for distribution. Packaged mashed potatoes are transported to a wide range of destinations, including supermarkets, restaurants, and food service providers across the country. Efficient logistics operations are key in this phase, as providers work to deliver products as quickly as possible while maintaining optimal conditions. Many factories partner with specialized logistics companies that understand the intricacies of food transportation, ensuring that the potatoes remain fresh and safe during transit. consumers can find bulk mashed potatoes in various forms, from ready-to-heat pouches to larger containers designed for food service. This versatility helps cater to the demanding food industry while still satisfying home cooks. Sustainability practices. In recent years, many potato processing factories have started adopting sustainable practices to minimize their environmental footprint. This includes sourcing potatoes from local farms, which reduces transportation emissions while supporting local economies. Additionally, factories are implementing waste reduction strategies, finding creative uses for byproducts. For example, potato peels are often repurposed for animal feed or composted, contributing to a closed-loop system. Many facilities also invest in energy-efficient technology and renewable energy resources to power their operations. By focusing on sustainability, the potato industry is not only meeting consumer demand for environmentally friendly products, but also ensuring the longevity of potato farming as a viable agricultural practice. Innovation and production, technological advancements continue to play a transformative role in bulk mashed potato production. Automation and robotics are increasingly prevalent, enhancing efficiency and ensuring consistent quality. Innovations such as improved mashing techniques and enhanced storage solutions contribute to the efficiency of the production line. Furthermore, data analytics are utilized to optimize operations, monitor quality, and predict demand, allowing factories to adapt to changing consumer preferences quickly. This continual pursuit of innovation is driven by reaching a growing market of consumers who desire convenience without sacrificing quality. The industry is evolving to meet these challenges head-on, ensuring that American consumers receive top-quality mashed potatoes that cater to their tastes and lifestyles. As we conclude our journey from field to factory, we see how the production of bulk mashed potatoes exemplifies American ingenuity in food production. From expert farmers selecting the perfect potatoes to advanced technologies ensuring quality and flavor, each step in this process is carefully crafted. Ultimately, the journey of bulk mashed potatoes is about delivering comfort and satisfaction in every scoop. Whether enjoyed at home, in a restaurant, or as part of a catered event, these mashed potatoes serve as a testament to the hard work and dedication of everyone involved in their production.
Did you know that milk powder isn't just a kitchen staple, but a game changer in food processing technology? It's the key to dairy consumption in areas where fresh milk isn't accessible. But have you ever thought about how regular milk is transformed into a fine powder that lasts for months? Let's take a deep dive into one of the most impressive food processing feats, the creation of bulk milk powder in megafactories. Before we start, make sure to hit that like button and subscribe for more mind-blowing insights into food production and technology, cow farming and silage feeding. The journey of milk powder begins long before it reaches a factory. It starts on dairy farms. Cows are the stars of the show here, and their health directly impacts milk quality. Farmers ensure cows are fed with high-quality silage, a type of fermented feed made from grass or crops like corn. The process involves harvesting crops during peak growth, chopping them, and storing them in silos where the lack of oxygen preserves nutrients. This rich feed ensures cows get essential nutrients year-round. Healthy cows produce high-quality milk, and that's step one in creating milk powder. Modern cow milking technology. Milking cows today isn't what it used to be decades ago. Modern dairy farms rely on automated milking machines that are both efficient and gentle. Here's how it works. Cows enter a milking parlor where machines equipped with soft rubber cups gently latch onto their teats. A vacuum system stimulates the udders, allowing milk to flow effortlessly into sanitized tanks. This process is designed to be stress-free for cows and highly hygienic for the milk. Every session is closely monitored, ensuring clean, fresh milk. Machines are sanitized thoroughly after every use to prevent contamination. Once collected, the milk is transferred to large refrigerated tanks ready for its next big step factory processing. Transportation to the factory. Once the milk is collected, it's transported to a processing plant in large refrigerated tankers. These tankers are insulated to maintain the milk's freshness during transit. Upon arrival, every drop of milk undergoes stringent quality tests. Factory technicians check for contaminants, bacteria, butterfat levels, and overall purity. only milk that meets strict safety and quality standards makes it into production. Pasteurization process. The next critical step is pasteurization, a process that guarantees milk safety. Here, milk is heated to around 72 degrees Celsius, 161 degrees Fahrenheit, for 15 seconds to kill any harmful bacteria. Then, it's rapidly cooled to 4 degrees Celsius to retain its natural flavor and nutritional value. This method, known as high-temperature short-time (HTST) pasteurization, not only keeps milk safe but also enhances its stability for the upcoming dehydration process. Milk concentration. Now comes the transformation. Pasteurized milk enters a concentration process where much of the water content is removed. First, the milk is preheated to about 60 degrees Celsius to preserve its flavor. It's then sprayed into a massive heated chamber. Hot air, often at temperatures of 150–180 degrees Celsius, evaporates around 80% of the water, leaving behind a thick concentrated milk product. This step sets the stage for the final dehydration process where magic truly happens. Spray drying, turning milk to powder. Here's where the liquid milk truly becomes powdered gold. The concentrated milk is pumped into a drying tower. At this stage, high-pressure nozzles atomize the milk into tiny droplets. Inside the drying chamber, air heated to around 220 degrees Celsius, 428 degrees Fahrenheit, evaporates the remaining moisture almost instantly. What's left is fine, dry milk powder. To ensure the milk powder dissolves smoothly in water, a small amount of soy lecithin is added. This gives the powder a uniform texture and makes it easier to mix when reconstituted. Did you know? It takes roughly 10 ounces of liquid milk to produce just 1 ounce of milk powder. Quality control and packaging. Before milk powder can hit the shelves, it must pass strict quality tests. Samples are checked for purity, moisture levels, and nutrient content. Once approved, the powder moves to the packaging area. Proper packaging is vital to protect the product from light, humidity, and air, factors that can shorten its shelf life. Milk powder is sealed in airtight bags labeled with brand and nutritional information and prepared for distribution. Global demand and use. Every year, the world consumes over 11 million tons of milk powder. Top consumers include countries like China, India, Indonesia, Vietnam, and Mexico. Why is milk powder so popular? Its long shelf life and easy transport make it invaluable for areas where refrigeration isn't an option. Plus, it's a versatile ingredient used in everything from baking and beverages to infant formulas. And there you have it, the incredible journey of milk powder from dairy farms to mega factories. It's a process that combines modern technology, precision, and quality control to create a product that's safe, versatile, and essential. Have you ever stopped to think about the journey of your favorite protein bar before it lands in your hand, ready to fuel your day? From raw ingredients to that perfectly wrapped package, the creation of protein bars is a marvel of modern food technology. In this video, we'll uncover the intricate process behind bulk protein bar production, where cutting-edge machinery and meticulous quality control come together to meet the growing demand for these nutritious snacks. If this sounds intriguing, hit the subscribe button and give us a thumbs up to support the channel. Let's dive in. Protein bars have transitioned from niche dietary supplements to a mainstream snack option adored by athletes, busy professionals, and health enthusiasts alike. The market, valued at billions of dollars, is projected to surpass $6 billion by 2029, a testament to their widespread popularity. This growth is driven by an increasing focus on health and fitness, the rise of high-protein diets, and the convenience protein bars offer as a quick energy boost on the go. Factories producing these bars are under constant pressure to meet soaring demand without compromising on quality. To achieve this, they've embraced state-of-the-art production techniques that balance efficiency, innovation, and sustainability. The journey begins long before the factory floor with the sourcing of raw materials. Protein is, of course, the star ingredient. Depending on the recipe, factories may use whey protein, derived from milk, soy protein, a plant-based alternative, or pea protein, popular for its allergen-free profile. These protein sources are chosen not only for their nutritional value, but also for their ability to blend seamlessly with other ingredients. Additional ingredients include oats, nuts, dried fruits, sweeteners, and flavorings, each serving a specific purpose. Oats add fiber, nuts contribute crunch and healthy fats, while dried fruits and sweeteners enhance taste. Even flavorings like chocolate or vanilla are selected with precision to ensure they align with the brand's target audience. Before entering the production line, raw materials are often pre-treated. For example, nuts may be roasted to bring out their natural oils and improve texture, while dried fruits might be diced into uniform pieces to ensure even distribution. Each of these preparatory steps is carefully monitored to uphold quality and consistency. Once all ingredients are ready, they are sent to industrial mixers where the magic of blending begins. Mixing is far from a simple task. It's a science of precision and balance. Each ingredient is added in carefully measured quantities, ensuring the protein content, flavor, and texture are up to standard. The mixers are enormous machines capable of handling large batches of ingredients at once. Equipped with advanced programmable logic controllers, PLCs, these mixers allow factory operators to adjust key parameters like mixing time, speed, and even temperature. For instance, certain recipes may require a slower mix to preserve the integrity of ingredients, like oats or nuts, while others benefit from higher speeds to create a smoother texture. Consistency is critical at this stage. A well-mixed batch ensures that each protein bar offers the same taste and nutritional profile, no matter which one you pick from the box. After mixing, the next step is homogenization, where the mixture is processed to eliminate any lumps or inconsistencies. This step ensures that every protein bar has a uniform composition, both in terms of texture and nutritional value. Homogenization is achieved through specialized equipment that applies pressure or mechanical force to break down the mixture into fine particles, resulting in a smooth, cohesive blend. This step is particularly important for bars containing multiple textures, such as crunchy nuts and chewy dried fruits. The process binds all components together, preventing separation during the subsequent stages of production. With the mixture prepared, it's time for compression, where the ingredients are shaped into long sheets. Using large rollers or presses, the mixture is compacted into thin, uniform sheets that serve as the base for individual bars. This step is crucial for ensuring that the final bars are dense enough to hold their shape without crumbling or breaking apart. Compression also enhances the texture of the bars, giving them a satisfyingly chewy consistency. Factories often calibrate their equipment to apply just the right amount of pressure. Too much can make the bars too hard, while too little might leave them fragile and prone to falling apart. Next comes the extrusion process, where the compressed sheets are formed into continuous bars. The mixture is forced through a die, a specialized tool that determines the bar's shape and size. This continuous strip of protein mixture is then cut into individual bars using high-speed cutters. What makes this step remarkable is its versatility. Extrusion allows factories to create bars of various shapes and sizes, from the standard rectangular bars we all know to smaller, bite-sized versions or even round energy bites. This adaptability enables manufacturers to cater to a wide range of consumer preferences. For many protein bars, the next step is adding a coating of chocolate, yogurt, or other toppings. This isn't just about taste, it's also about creating a product that's visually appealing and marketable. The bars pass through an enrobing machine where they are evenly coated with the chosen topping. Once coated, the bars are sent through a cooling tunnel, a carefully controlled environment where the coating solidifies. This step is critical for ensuring that the bars maintain their shape and don't stick together during packaging. Throughout the entire production process, factories employ rigorous quality control measures. From automated sensors that monitor the size and shape of each bar to visual inspections for defects, every bar undergoes multiple checks before it's approved for sale. Advanced technology, such as AI-driven systems, plays a key role here. These systems can detect even the slightest inconsistencies, ensuring that only bars meeting strict quality standards make it to the next stage. Once the bars are ready, they move to the packaging phase. High-speed machines wrap each bar individually, using materials that protect them from moisture and oxygen, preserving their freshness and extending shelf life. The packaging is also designed to be visually appealing, with colorful designs and clear nutritional information that catch the eye of consumers. For multi-packs, the individually wrapped bars are grouped into boxes, which are assembled automatically. This step is particularly important for meeting the diverse needs of retailers, from single bars sold at convenience stores to larger packs found in supermarkets. Each package is labeled with crucial information, such as the product name, nutritional facts, and batch number. This labeling ensures traceability, allowing manufacturers to track each bar from production to sale. In the rare event of a recall, this system ensures that affected products can be identified and removed swiftly. The protein bar industry thrives on innovation, constantly introducing new flavors and ingredients to attract consumers. From exotic flavors like matcha and salted caramel to functional ingredients like collagen and probiotics, the possibilities are endless. Factories equipped with modern technology can experiment with and scale up new recipes quickly, staying ahead of consumer trends. Sustainability is becoming a cornerstone of modern protein bar production. Factories are adopting eco-friendly practices, such as sourcing ingredients from sustainable farms, using recyclable packaging, and minimizing energy consumption through efficient machinery. These efforts not only reduce environmental impact, but also resonate with environmentally conscious consumers. The ability to scale production efficiently is what allows factories to meet the ever-growing demand for protein bars. By leveraging automation and advanced machinery, manufacturers can produce millions of bars daily, ensuring a steady supply for global markets. As technology continues to evolve, the future of protein bars looks brighter than ever. Innovations in AI, robotics, and food science will make production even more efficient, while new ingredients and flavors will keep consumers excited. The focus on sustainability will also drive the development of greener production methods, ensuring that protein bars remain a staple for generations to come. So there you have it, the journey of protein bars from raw ingredients to the final packaged product. It's a testament to the power of modern food processing technology and innovation. Have you ever wondered how millions of sheep are processed efficiently in American factories without compromising quality? In today's rapidly advancing agricultural landscape, modern sheep processing factories have revolutionized the way we handle and prepare lamb for consumption. Utilizing cutting-edge automation and technology, these facilities streamline every step of the process, from slaughtering to packaging, ensuring that consumers receive the finest lamb chops and other premium products. Advanced automation in sheep processing. Traditional sheep processing methods are labor-intensive and time-consuming, often leading to inefficiencies and inconsistencies in product quality. Enter the era of automation. Modern sheep processing factories are equipped with state-of-the-art machinery that automates critical processes, such as slaughtering, skinning, and evisceration. These automated systems ensure precise cuts and minimize human error, resulting in uniform lamb cuts that meet the high-quality standards demanded by chefs like Bobby Flay, Ramsay, etc. Sustainable practices in sheep processing. Environmental concerns are increasingly pressing, with traditional sheep processing methods often contributing to significant waste and resource depletion. Modern sheep processing factories in America are adopting sustainable practices to address these challenges. Innovations such as waste recycling systems, energy-efficient machinery, and water conservation techniques are integral to their operations. Additionally, byproducts from the processing are repurposed into valuable products like fertilizers and animal feed, reducing overall waste. Ensuring food safety and quality. Food safety remains a paramount concern, with the risk of contamination posing serious health hazards to consumers. Modern sheep processing factories prioritize food safety through stringent quality control measures and advanced monitoring systems. From the moment sheep enter the facility, every step is meticulously monitored to prevent contamination. Automated sanitization processes and real-time quality checks ensure that the final lamb products are safe for consumption. Enhancing worker safety with technology. Sheep processing is a physically demanding job, often exposing workers to potential hazards and health risks. To mitigate these risks, modern sheep processing factories integrate safety-enhancing technologies. Automated machinery reduces the need for manual handling, minimizing the risk of injuries. Additionally, ergonomic workplace designs and advanced ventilation systems protect workers from harsh environments and improve overall workplace safety. Precision cutting and packaging technologies. Inconsistent cutting and packaging can lead to product wastage and dissatisfaction among consumers seeking uniform lamb chops. Modern processing factories employ precision cutting machines that deliver consistent and accurate cuts, ensuring uniformity in every lamb chop. Advanced packaging technologies then seal the products in airtight, vacuum-sealed packs, preserving freshness and extending shelf life. These technologies cater to both retail and culinary needs, ensuring that chefs like Bobby or Gordon receive top-quality lamb for their signature dishes. Integration of IoT and data analytics. Managing large-scale sheep processing operations can be complex, with numerous variables affecting efficiency and output quality. The integration of Internet of Things, IoT devices, and data analytics into sheep processing factories provides real-time monitoring and data-driven decision-making. Sensors track everything from machinery performance to environmental conditions, while analytics platforms process this data to optimize operations, predict maintenance needs, and enhance overall efficiency. Quality assurance through blockchain technology. Traceability and transparency in the food supply chain are critical for ensuring product authenticity and consumer trust. Blockchain technology offers an immutable ledger that tracks every step of the sheep processing journey from farm to table. By recording detailed information about each batch of sheep, including origin, processing steps, and quality checks, blockchain ensures complete traceability and transparency. This technology reassures consumers about the authenticity and quality of their lamb products. Energy efficiency and cost reduction. High energy consumption in sheep processing factories leads to increased operational costs and environmental impact. Modern sheep processing facilities are adopting energy-efficient technologies to reduce their carbon footprint and operational expenses. Innovations such as LED lighting, energy-efficient motors, and heat recovery systems optimize energy usage. Additionally, smart energy management systems monitor and adjust energy consumption in real time, ensuring maximum efficiency. Meeting global demand with scalable technology. With the rising global demand for lamb products, traditional processing methods struggle to keep up with the scale required. Scalable technology solutions in modern sheep processing factories allow for the seamless expansion of operations to meet growing demand. Modular processing lines and flexible automation systems can be easily adjusted to handle varying volumes, ensuring that factories can scale up production without compromising on quality or efficiency. Enhancing flavor and tenderness through technology. Consumers crave lamb that is not only safe and consistent, but also exceptionally flavorful and tender. Advanced processing techniques such as controlled aging and precise temperature management enhance the flavor and tenderness of lamb. Modern factories utilize specialized equipment to monitor and adjust conditions during processing, ensuring that each lamb chop meets the desired taste and texture standards. Workforce training and development in high-tech environments. Integrating advanced technology in sheep processing requires a skilled workforce, which can be challenging to develop and maintain. Modern sheep processing factories invest in comprehensive training programs to equip their workforce with the necessary skills to operate and maintain high-tech machinery. Continuous education and development initiatives ensure that employees are proficient in the latest technologies and best practices, fostering a knowledgeable and adaptable workforce. Reducing waste through precision technology. Excessive waste in sheep processing not only increases costs, but also has environmental repercussions. Precision technology plays a pivotal role in minimizing waste during the sheep processing process. Automated cutting systems ensure that each part of the sheep is utilized effectively, reducing unnecessary waste. Additionally, advanced sorting and grading technologies optimize the use of each animal, ensuring that every component is processed and utilized to its fullest potential, enhancing supply chain efficiency with technology. Managing the supply chain for sheep processing involves multiple stages, each with its own set of challenges and inefficiencies. Integrated supply chain management systems streamline the entire sheep processing workflow, from procurement to distribution. Real-time tracking, automated inventory management, and seamless communication between different stages ensure that the supply chain operates smoothly and efficiently. This integration minimizes delays and ensures timely delivery of high-quality lamb products to the market. Future innovations in sheep processing technology. The sheep processing industry is continually evolving, with emerging technologies poised to further transform operations and product offerings. Looking ahead, innovations such as artificial intelligence, AI, machine learning, and robotics are set to revolutionize sheep processing even further. AI-driven predictive maintenance can foresee equipment failures before they occur, while machine learning algorithms optimize processing parameters for maximum efficiency and quality. Robotics will take on more complex tasks, enhancing precision and reducing the need for manual labor. The role of innovation in meeting consumer expectations. Consumers today have higher expectations for the quality, safety, and sustainability of their food, including lamb products. Innovation is key to meeting and exceeding these consumer expectations. Modern sheep processing factories leverage the latest technologies to enhance every aspect of production, from ensuring traceability and food safety to improving the flavor and tenderness of lamb. By staying at the forefront of technological advancements, these factories can deliver lamb products that align with consumer values and preferences. Collaboration with culinary experts for product development. Creating lamb products that cater to diverse culinary applications requires a deep understanding of both processing and culinary arts. These collaborations help in designing cuts and packaging that enhance the cooking experience and meet the high standards of professional kitchens. Feedback from chefs ensures that the lamb products are optimized for flavor, tenderness, and presentation. Marketing and branding of modern sheep processing products. Effective marketing and branding are essential for differentiating high-quality lamb products in a competitive market. Sheep processing factories invest in robust marketing and branding strategies to highlight the superior quality and technological advancements of their lamb products. Highlighting the use of modern processing technologies and sustainable practices strengthens the brand's appeal. Adapting to market trends and consumer preferences. The food industry is dynamic, with consumer preferences and market trends constantly evolving. Modern sheep processing factories stay ahead by closely monitoring market trends and adapting their production accordingly. Whether it's the rising demand for organic lamb, value-added products like seasoned lamb chops, or convenience-oriented packaging, these factories are agile and responsive. Utilizing data analytics and consumer feedback, they continuously refine their offerings to align with shifting preferences. Conclusion: the future of sheep processing in America. As the demand for high-quality lamb products continues to grow, the sheep processing industry must evolve to meet these expectations sustainably and efficiently. Modern sheep processing factories in America are at the forefront of this evolution, leveraging advanced technologies and sustainable practices to process millions of sheep each year. From automation and precision cutting to blockchain traceability and energy-efficient operations, these factories exemplify the perfect blend of tradition and innovation. Final thoughts. Modern sheep processing factories are revolutionizing the way we produce and consume lamb. By integrating advanced technologies, sustainable practices, and a focus on quality and safety, these facilities ensure that millions of sheep are processed efficiently each year, delivering top-notch lamb chops and other products to consumers and culinary experts alike. Whether you're a home cook looking to prepare the perfect lamb dish, or a chef like Bobby Flay seeking premium ingredients, the innovations in sheep processing guarantee that you receive the best quality lamb available. As the industry continues to evolve, we can expect even greater advancements that will further enhance the quality, sustainability, and accessibility of lamb products, making them a staple in kitchens around the world. Spicy chicken sausages have become a beloved staple in kitchens around the world, whether you're grilling them for a barbecue or slicing them into a pasta dish. But have you ever stopped to think about how they're made, especially in a factory capable of producing thousands of sausages a day? This factory has mastered the craft, blending traditional recipes with cutting-edge machinery to churn out sausages that deliver on both taste and quality. The process starts with sourcing fresh, high-quality chicken. It's not just about the meat. The fat and skin are equally important. These components contribute to the sausage's rich flavor and juicy texture. The factory's team works closely with suppliers to ensure that every batch of chicken meets their exacting standards. Like, share, and subscribe to see how only the best cuts make it into the production line. And even at this early stage, quality control checks are in full swing. Once the chicken arrives at the factory, it's prepped for processing. Large, fresh pieces of chicken, along with the skin and fat, are cut into smaller chunks to make them easier to handle in the next steps. This isn't done manually. Industrial slicers take over, operating at incredible speeds to ensure uniformity. Uniform cuts are critical for consistent grinding and blending later on. The slicing machines are marvels of engineering, equipped with sensors to ensure precision. They can process hundreds of pounds of chicken in minutes, making it possible to keep up with the factory's high production demands. As the chicken pieces move along the conveyor belt, they're inspected again to ensure only the highest quality pieces make it to the next stage, grinding the meat. Next, the chopped chicken moves to the grinders. These machines are the unsung heroes of sausage production, breaking down the chicken into coarse ground meat. Imagine a machine so powerful that it can process hundreds of pounds of chicken per minute, yet delicate enough to ensure the meat retains its natural texture. The grinding stage is about more than just breaking down the meat. It's about creating the perfect base for the sausage mixture. The consistency here matters because it sets the stage for everything that comes next. As the ground meat pours out of the grinder, it's collected in large bins and transported to the blending machines for the next step. Now it's time for the blending stage, where the ground chicken is combined with finely blended fillings. This step smooths out the texture of the meat while incorporating the fat and skin more evenly. The blending machines are massive, capable of holding hundreds of pounds of meat at a time. These machines don't just mix, they fold, churn, and aerate the mixture to create a consistent, silky texture. Advanced sensors monitor the temperature and blending speed, ensuring that the mixture doesn't overheat or lose its moisture. At this point, the mixture is ready for the most exciting step, seasoning. Seasoning is what transforms plain ground chicken into the bold, spicy sausages we know and love. Factories use carefully crafted spice blends, often developed over years of experimentation. Paprika, chili powder, garlic, onion, and black pepper are common ingredients, but the exact blend is often a closely guarded secret. Automated dosing systems measure out the perfect quantities of each spice, ensuring consistency across thousands of batches. This precision is key because even a slight variation in spice levels can affect the flavor. Once the spices are added, the mixture is kneaded thoroughly to ensure the seasonings are evenly distributed. The aroma at this stage is absolutely mouth-watering, a tantalizing preview of the finished product. With the mixture seasoned to perfection, it's time to shape the sausages. This is where automated filling machines come into play. These machines are incredibly efficient, piping the sausage mixture into casings with remarkable speed and accuracy. The casings, whether natural or synthetic, are chosen for their ability to hold the sausage's shape during cooking. As the sausages are filled, they are linked together in neat rows, creating that familiar sausage chain you often see in butcher shops. The filling machines ensure that every sausage is the same size and weight, which is crucial for even cooking in the later stages. 7. Steaming for perfect texture. Once the sausages are formed, they move to the steaming chambers. This step is vital for cooking the sausages while locking in their juices. The steaming process ensures the sausages cook evenly from the inside out, preserving their moisture and enhancing the flavors of the spices. Industrial steaming chambers are designed to handle large volumes of sausages at once. The sausages are placed on racks and exposed to carefully controlled steam for a set amount of time. This process not only cooks the sausages, but also sets their texture, giving them that signature snap when you bite into them. After steaming, the sausages need to cool down quickly to maintain their structure. The first step in this process is a cooling shower, where jets of cold water rapidly bring down the sausage's temperature. This is followed by a water soak, which ensures every sausage is evenly cooled. For an extra layer of cooling, ice cubes are added to the water bath. This step is particularly important for preserving the sausage's texture and preventing overcooking. By the end of this stage, the sausages are fully set and ready for peeling. Peeling is one of the most mesmerizing steps in the production process. High-speed peeling machines remove the outer casing from the sausages without damaging their shape. These machines use a combination of pressure and precision to strip away the casing in seconds. Watching these machines in action is a true marvel. They can process thousands of sausages in the time it takes you to fry one at home. By the end of this stage, the sausages are smooth, shiny, and ready for the next step. Packaging is about more than just aesthetics. It's a critical step in preserving the sausage's freshness and flavor. The peeled sausages are neatly arranged on conveyor belts and sent to the packaging station. Automated systems wrap them in airtight packaging, which helps prevent spoilage and extends their shelf life. Each package is labeled with essential information, including nutritional details, cooking instructions, and expiration dates. Some packages even feature QR codes that allow consumers to trace the sausage's journey from factory to store. If you're enjoying this behind-the-scenes look at sausage production, don't forget to like this video and hit subscribe. We've got plenty more factory tours and food production stories to share with you. Food safety is a top priority in any factory, and this one is no exception. Every package of sausages passes through a metal detector to ensure there are no foreign objects in the product. This step is part of the factory's rigorous quality control process, which ensures that every sausage meets the highest safety standards. To lock in the sausage's freshness, they are subjected to blast freezing. This involves exposing the sausages to temperatures well below freezing in a matter of minutes. The rapid freezing process prevents the formation of large ice crystals, which can compromise the sausage's texture. Blast freezing also ensures that the sausages remain flavorful and ready for transport to stores and restaurants around the world. It's the final step before the sausages are shipped out, completing their journey through the factory. And here we have the final product, spicy chicken sausages that are ready to hit store shelves. These sausages are a testament to the factory's commitment to quality, flavor, and innovation. Whether you're frying them up for breakfast or grilling them for dinner, they're guaranteed to satisfy your cravings. To wrap up, the factory staff treat us to a plate of fried spicy chicken sausages. Watching them sizzle in the pan is a feast for the senses, and the first bite is pure perfection. Crispy on the outside, juicy on the inside, and packed with bold, spicy flavor. It's the perfect end to an incredible journey. From fresh chicken to your plate, the journey of a spicy chicken sausage is a blend of tradition, technology, and mouth-watering flavor. Imagine sitting at your holiday table, the centerpiece a perfectly roasted turkey, its crispy skin crackling under the carving knife. Have you ever wondered about the whirlwind journey that brought this bird from hatchery to holiday feast? Beneath that golden brown exterior is an elaborate chain of genetics, technology, animal husbandry, and logistics. An entire hidden world dedicated to delivering millions of turkeys to our plates every year. In this video, we'll pull back the curtain on modern turkey production, tracing each step with a fresh perspective that challenges us to think deeper about our food choices. From the sophisticated science of breeding and biosecurity to the vast processing plants humming with automated efficiency, you'll see how every detail from egg incubation to distribution plays a pivotal role. Get ready to discover the story few of us know about, yet almost all of us taste when that holiday meal arrives. By understanding the journey from egg to table, we gain insights into the breeding techniques, housing systems, feeding regimens, and health protocols that underpin this vast industry. We'll also touch on sustainability efforts, animal welfare considerations, and how technologies like automation and biosecurity measures help maintain efficiency and safety. This video aims to give you a closer look at a process that is both scientifically advanced and economically significant. The global turkey industry. A brief overview. Turkey farming has evolved significantly over the past few decades, becoming a global enterprise that supplies fresh and processed products to countless markets. The U.S. remains a major player, but countries like Brazil, Canada, and several European nations also have thriving turkey sectors. Consumers seek out turkey for its lean protein content, cultural significance, and versatility, from whole roasted birds to deli slices and ground meat. Large agribusinesses often practice vertical integration, handling everything from hatchery operations to processing. This consolidation improves consistency, lowers costs, and meets strict market standards. At the same time, innovation in genetics, feed formulations, and disease control contributes to improved performance and quality. Despite competition from other proteins like chicken, turkey continues to carve out a strong niche, particularly during festive times when demand surges. Turkey breeding and genetics. Modern commercial turkey breeds are carefully selected for traits like rapid weight gain, robust breast development, and disease resistance. The well-known broad-breasted turkey is a classic example of selective breeding optimized for meat production. Achieving these traits, however, requires a delicate balance to avoid potential genetic issues like reduced fertility or susceptibility to certain ailments. Breeding companies run specialized programs, often housing parent stock in controlled environments to ensure consistent egg production. Advanced genetic testing helps track lineage, monitor performance, and maintain genetic diversity. Eggs are collected, graded, and sent to hatcheries outfitted with sophisticated systems that automate temperature, humidity, and rotation. This upstream focus on genetics and reproduction sets the tone for the entire supply chain, aiming to produce healthy poults capable of strong growth. Hatcheries, where life begins. At hatcheries, fertile turkey eggs undergo a detailed incubation process that lasts about 28 days. During this period, the eggs are kept in high-tech machines that regulate temperature, humidity, and gentle rotation, mimicking natural conditions. Toward the end of incubation, eggs are moved to hatching units where the poults emerge. Immediately after hatching, poults are sorted, graded, and given vaccinations against common diseases like avian influenza. Automated conveyor belts often move the chicks through various stations to reduce manual handling and improve efficiency. Poults then receive their first feed and water to jumpstart growth. Maintaining strict sanitation in hatcheries is crucial, as any contamination can spread quickly and compromise an entire flock. Early rearing, the first few weeks. After leaving the hatchery, the young turkeys, or poults, are transported to brooder houses designed to keep them warm and protected. Proper temperature control is essential, as these birds are sensitive to environmental changes. Farmers use large insulated barns equipped with automated feeding and watering systems, ensuring the poults receive constant nourishment. High-protein starter feed helps them grow rapidly. Bedding materials like wood shavings or straw cushion their legs and absorb moisture. Lighting schedules are carefully managed, often with dimmer settings to encourage rest and reduce stress. Farm staff monitor bird behavior closely. If poults huddle tightly, it may signal cold conditions, prompting adjustments in heat or ventilation. The goal is to transition the flock smoothly into the next growth phase with minimal losses. Growing phase, from poult to mature turkey. Once turkeys outgrow the brooding environment, they are moved to grow-out barns. These larger facilities can house thousands of birds under one roof. Automated feeding systems deliver carefully formulated diets consisting primarily of corn, soybean meal, and essential vitamins. The barns also have advanced ventilation systems to bring in fresh air and remove ammonia generated by manure. Farm managers collaborate with nutritionists and veterinarians to track bird health. As the turkeys mature, their feed composition shifts to balanced protein and energy intake, promoting muscle development rather than excess fat. Enrichment items such as straw bales may be placed within barns to stimulate natural behaviors and reduce aggression. By the time turkeys near market weight, usually between 15 and 40 pounds, efficient management has optimized feed conversion and minimized stress. Health management and biosecurity. Keeping disease at bay is a critical aspect of large-scale turkey farming. Farms implement biosecurity measures like disinfecting vehicles, restricting visitor access, and requiring protective clothing. Frequent testing for pathogens and routine vaccinations further shield the flock from common poultry diseases. While some farms administer antibiotics, there is growing consumer demand for antibiotic-free turkey, prompting many operations to adopt alternative health strategies. Veterinarians conduct regular flock checkups, often testing blood and fecal samples to detect early signs of illness. If a disease is identified, affected birds may be quarantined or treated promptly to prevent outbreak escalation. Farms also keep detailed records of medications and vaccinations to maintain transparency and meet regulatory requirements. Overall, disease prevention not only ensures healthier birds, but also protects product quality and farm profitability. Pre-harvest preparation. As turkeys approach market weight, producers coordinate with processing plants to schedule transport. Minimizing stress is vital at this stage because high stress can reduce meat quality. Farmers typically gather the birds into holding areas within the barn, simplifying the loading process once trucks arrive. Because temperature extremes can stress turkeys, loading often occurs in cooler hours to maintain comfort and prevent overheating. Transport crates or modules designed for proper ventilation are used to keep air circulating around the birds. Producers check that each flock meets plant specifications for age and weight, and all required health certifications are finalized before the birds depart. This preparation sets the stage for a smooth transition into the processing phase. Transportation and arrival at the processing plant. The distance between farm and processing facility varies. Shorter hauls tend to be better for bird welfare and cost efficiency. Upon arrival at the plant, trucks drive into a secure receiving area where workers unload the turkeys and allow them to rest briefly in holding pens. This holding time is crucial for reducing stress. Proper handling techniques are emphasized to avoid injuries like bruising that can affect meat quality. Processing plants often follow a strict schedule, moving the birds through inspection, stunning, and slaughter in a continuous flow. By carefully timing each stage, facilities maintain high throughput without sacrificing humane treatment or product consistency. Stunning and slaughter methods. Humane slaughter practices are mandated by law in many regions. One common method involves electrically stunning turkeys as they pass through a water bath while shackled, rendering them unconscious before bleeding. Another approach is controlled atmosphere stunning, KS, where birds are exposed to a gas mixture that causes unconsciousness without requiring them to be shackled while fully conscious. Both methods aim to minimize pain and distress. After stunning, an automated or manual cut severs the major blood vessels in the neck, allowing the turkeys to bleed out while unconscious. Inspectors frequently observe this process to ensure compliance with welfare regulations. The methods used directly impact both ethical considerations and the overall quality of the final product. Scalding, defeathering, and evisceration. Following exsanguination, turkeys enter a scalding tank of hot water that loosens feathers for easier removal. Automated defeathering machines equipped with rubber fingers then strip feathers as the carcasses pass through. This step is remarkably efficient, enabling large plants to process thousands of turkeys each hour. Next, the evisceration line removes internal organs. Skilled workers and automated systems collaborate here, ensuring that edible parts like the heart, liver, and gizzard, known as giblets, are gathered separately. Any carcass showing signs of disease or contamination is flagged for further inspection. Plants uphold strict sanitation measures, equipment is disinfected regularly, and staff wear protective gear to maintain hygiene standards. Chilling and quality control. Prompt chilling is critical for inhibiting bacterial growth. Water immersion chilling submerges turkeys in cold water tanks, while air chilling uses chilled air to rapidly reduce the bird's temperature. Regardless of the method, the goal is to keep microbial counts in check. Quality control teams examine each turkey for defects, bruising, or leftover feathers. Microbial tests are also conducted at regular intervals, ensuring compliance with food safety regulations. Carcasses that fail checks are diverted, preventing potential hazards from entering the marketplace. After passing these inspections, turkeys may be packaged whole or segmented into breasts, thighs, wings, or ground products. Labels include nutritional information and traceability codes, which allow any recalls or issues to be tracked back to specific batches. Distribution and retail. Once packaged, turkeys are transferred to temperature-controlled storage areas before shipment. Depending on orders and shipping distances, they may travel by refrigerated trucks to distribution centers or direct to retailers. Grocery stores typically plan turkey orders weeks ahead of major holidays to ensure adequate inventory. Cold chain management is paramount during transit and storage, preserving freshness and safety. Some consumers prefer fresh, never-frozen turkeys, while others find convenience in frozen options. Restaurants and food service providers often receive portion cuts, which are easier to handle for large-scale meal prep. Effective logistics from farm to store ensure that supermarkets and restaurants can reliably stock turkey products year-round and during holiday rushes. Sustainability and ethical considerations. As global demand for turkey rises, sustainability becomes a pressing topic. Large farms consume considerable water and feed resources, and proper waste management is essential to reduce environmental impact. Many producers explore renewable energy options, water recycling, and more efficient feed conversion ratios to limit their ecological footprint. Animal welfare groups, meanwhile, push for expanded living spaces, improved lighting, and reduced stocking densities. Laws in certain regions mandate specific welfare standards, while consumer pressure encourages producers to adopt better practices. Despite potential increases in production costs, these measures can open premium markets for products labeled organic, free-range, or antibiotic-free. Ongoing research in biotechnology and precision farming tools also supports more ethical and eco-friendly approaches, shaping the future of commercial turkey farming. Conclusion and consumer awareness. Raising and processing millions of turkeys annually is a highly coordinated endeavor involving genetics, specialized housing, meticulous health protocols, and extensive logistics. Each link in the chain, from egg to final product, must operate efficiently to provide a consistent supply of turkey meat. Modern operations employ advanced technology to track bird growth, reduce disease risks, and streamline processing, all while striving to meet evolving consumer and regulatory demands. As a consumer, understanding these processes can help you make more informed choices about how your food is produced. Whether you seek organic, free-range, or conventional turkey, awareness of the industry's emphasis on biosecurity, humane handling, and sustainability can guide your decisions. While challenges like environmental impact and animal welfare continue to spark debate, the turkey industry also serves as a case study in how large-scale agriculture can adapt. Did you know that every single McDonald's hamburger has a story? a story that begins far away from the golden arches and goes through an incredible journey before it lands in your hands. Today, we're going to explore the extraordinary process of how McDonald's hamburgers are made, from the humble beginnings of their raw ingredients to the sizzling final product. It's a journey that involves innovation, precision, and a touch of history, all coming together to create one of the most iconic foods of modern times. Let's take a step back in time to understand where it all began. McDonald's wasn't always the global fast food powerhouse we know today. In 1940, two brothers, Richard and Maurice McDonald, opened a small drive-in restaurant in San Bernardino, California. Their vision was simple: serve quality food fast. In those early days, hamburgers weren't the industry-defining item they are now. It wasn't until Ray Kroc joined the team in 1954 and expanded McDonald's into a franchise model that the humble hamburger became a symbol of consistency, efficiency, and flavor. It wasn't just a meal. It became an experience, one that millions around the world associate with childhood memories, road trips, and the comforting familiarity of the golden arches. So, how does McDonald's ensure that every hamburger tastes the same, whether you're grabbing a bite in Texas or New York City? It all starts with the sourcing of the raw ingredients. McDonald's prides itself on using 100% pure beef for its patties. That's right, no fillers, no preservatives, just beef. But not just any beef will do. The company works with suppliers who meet rigorous standards to ensure the highest quality. These suppliers source cattle raised on farms across the United States, adhering to strict guidelines for animal welfare and sustainability. The beef must have the right balance of fat and lean meat, which is crucial for creating that juicy, flavorful patty we all know and love. Once the cattle are raised and the beef is harvested, it's transported to state-of-the-art processing facilities. This is where the magic begins. At these facilities, the beef is inspected, trimmed, and ground to the perfect consistency. The grinding process is a marvel of modern engineering. Large cuts of beef are passed through industrial grinders that ensure a consistent texture, eliminating any guesswork. After grinding, the beef is shaped into patties using high-speed machinery that forms each patty to the exact specifications of McDonald's iconic burgers. These machines work with incredible precision, churning out thousands of patties an hour, each one identical in size and shape. But we're not done yet. The patties are then flash frozen to lock in their freshness and flavor. This step is critical because it ensures that the patties maintain their quality from the moment they leave the factory to the time they're cooked on the grill. Flash freezing involves rapidly lowering the temperature of the patties to preserve their natural juices, making sure every bite is as satisfying as the last. Once frozen, the patties are packaged and sent to distribution centers, where they're stored in temperature-controlled environments before being delivered to McDonald's restaurants around the country. Now let's talk about the other essential components of the hamburger, starting with the buns. McDonald's buns are just as important as the beef patties. They're soft, fluffy, and slightly sweet, providing the perfect complement to the savory beef. The journey of a McDonald's bun begins with high-quality wheat. This wheat is grown in fields across the U.S., harvested, and milled into flour. The flour is then sent to specialized bakeries that work exclusively for McDonald's. Here, the dough is mixed, proofed, and baked to perfection. The buns are sliced and packaged before being shipped to McDonald's locations, ensuring they arrive fresh and ready to serve. Of course, no hamburger is complete without its toppings. The lettuce, tomatoes, and onions used in McDonald's burgers are sourced from farms that follow strict quality standards. The lettuce is crisp and fresh, the tomatoes are ripe and juicy, and the onions add just the right amount of zing. These vegetables are carefully grown, harvested, and transported to processing facilities where they're washed, sliced, and packaged. The attention to detail here is astounding. Every slice of tomato and piece of lettuce is checked to make sure it meets McDonald's exacting standards. Now, let's address one of the unsung heroes of the McDonald's hamburger, the pickles. These tangy slices are made from cucumbers that are brined in a special solution to achieve their signature flavor. The pickles add a burst of acidity that perfectly balances the richness of the beef and the sweetness of the bun. Once all the ingredients are ready, they're sent to McDonald's restaurants, where the final assembly takes place. At the restaurant, the patties are cooked on flat-top grills. The grilling process is an art in itself. The patties are cooked to precise temperatures to ensure they're juicy and flavorful, and they're seasoned with a simple sprinkle of salt and pepper. While the patties are grilling, the buns are toasted to enhance their flavor and texture. This step might seem small, but it makes a big difference in the overall experience of the burger. The assembly process is where everything comes together. The toasted bun is placed at the bottom, followed by the cooked patty. Then comes a dollop of ketchup and mustard, a couple of pickles, and a slice of fresh onion. Finally, the top bun is placed, completing the burger. Each burger is wrapped or boxed with care, ensuring it stays warm and intact until it reaches the customer. What makes this entire process so remarkable is the consistency. Whether you're in Los Angeles or Chicago, your McDonald's hamburger will taste the same, thanks to the meticulous attention to detail at every step of the journey. This consistency is no accident. It's the result of decades of refinement and innovation. But McDonald's isn't just about making great food, it's also about doing it responsibly. The company is committed to sustainability, from the farms where its ingredients are grown to the factories where they're processed. McDonald's works with suppliers who use eco-friendly farming methods, such as crop rotation and water conservation. The factories that produce the patties and buns are designed to minimize waste and energy consumption, making the process as efficient as possible. So, the next time you bite into a McDonald's hamburger, take a moment to appreciate the incredible journey it took to get to you. From the farm to the factory to the restaurant, every step is a testament to the power of innovation, quality, and care.
Did you know that the sizzling strip you toss into a pan each morning may have traveled farther, been engineered more carefully, and touched more technology than the smartphone in your pocket? Have you ever wondered how the planet's love affair with bacon, a devotion so deep that more than 50 million metric tons of pork end up as bacon every year, is satisfied by only a handful of mega-scale factories? How does a single facility transform thousands of animals a day into uniform, paper-thin ribbons of smoky, salty perfection that land in grocery cases from Arizona to Abu Dhabi? Let's step inside the biggest bacon plant on Earth and track every moment of the journey. From a piglet's first meal to the second the vacuum-sealed package hisses open in your kitchen, our story begins on specialist pig farms that look more like nutrition laboratories than rustic barns. Genetics teams select lineages prized for broad, meaty bellies and steady temperaments, traits that make handling easier and keep stress hormones from toughening meat. Within climate-controlled nurseries, the piglets arrive, each barely a kilogram but already tagged and logged in a cloud database that will trace them throughout their short lives. Automatic feeders dispense exact rations of corn, wheat, soy protein, mineral premixes, and vitamins calibrated to accelerate growth while encouraging a luxurious layer of interlacing fat. That fat, more than anything, is the reason bacon crackles into crunchy gold later. Without it, the meat would dry and curl like old parchment. Some boutique operations even spike feed with a measured splash of beer, claiming the barley sugars foster creamier fat, though large integrators mostly rely on rigorously tested grain formulas. 6 months later, the pig has multiplied its birth weight more than 100-fold, tipping the scales at roughly 110 kilograms and sporting a firm, symmetrical midsection that butchers call the money muscle. Farm records note health parameters from birth, vaccination dates, antibiotic-free status, feed conversion rates, and even step counts from floor sensors that detect lethargy long before illness shows. When the schedule calls for shipping, handlers guide the animals down wide, non-slip loading ramps using plastic paddles and low whistles in order to keep heart rates low and muscles relaxed. The livestock trucks waiting outside look nothing like ordinary trailers. Perforated aluminum walls promote airflow. Retractable roofs soften direct sun, and shock-absorbing axles cushion every pothole. GPS and interior temperature probes send live readings to the factory so staff can adjust lairage environments ahead of arrival. 2 hours out, a control room inside the plant springs into action. Chilled holding pens are prepared, and antimicrobial misting nozzles hiss like sprinklers over stainless steel grates to neutralize any microbes the pigs might shed. When the convoy rolls through the biosecure gate, each truck drives onto an automated scale where RFID ear tags are scanned, linking live weight to the farm's digital file. A quick exterior wash blasts dust and road grit away, and the animals walk single file into roomy pens, furnished with fresh drinking nipples and padded floors. Federal guidelines mandate a several-hour rest to let adrenaline levels drop. Lower stress means paler, firmer, non-exudative meat, the gold standard for premium bacon. The first truly irreversible moment comes in the stunning chamber. Carbon dioxide gas remains the industry's favorite method because it is swift and minimizes struggling. A slow conveyor lowers small groups of pigs into a foamy, invisible pool of COs, and within 10 seconds they slip into unconsciousness. Immediately afterward, each animal is hoisted by the hind leg onto an overhead rail, and a precise incision at the carotid guarantees complete exsanguination in under 5 minutes. Modern abattoirs reclaim that blood for plasma protein supplements, proving that in a high-volume factory, very little goes unused. Next is the scalding tank, a 60-degree bath no deeper than a swimming pool filled with continuously overflowed filtered water. Submersion for 3 minutes loosens hair follicles, prepping the carcass for the deherring machine, an iron cylinder lined with rows of rubber paddles that slap the skin clean at a dizzying 40 revolutions a minute. Yet even this mechanical thoroughness leaves micro-stubble, so the carcass glides through a singeing tunnel where blue-white burners lick away any remaining hair and, crucially, caramelize the outer collagen layer to lock in moisture. A final polish by whirring. Bright LEDs illuminating stainless steel from floor ceiling. One technician scores a neat circle around the anus and ties it closed with food-safe string so digestive bacteria stay sealed off. Another slices from sternum to pelvic bone, careful to keep the blade hugging the inner wall so the equipment-wide vacuum hose can slip in and siphon away the pluck, lungs, heart, and viscera in one clean draw. Offal goes straight into chilled tote bins for rendering into medical gelatin, bakery shortening, or pet food. Paths as meticulously regulated as the bacon line itself. A high-speed bandsaw now splits the carcass along the spine. Two symmetrical halves travel via twin rails through a blast chiller that drops core temperature from 38 degrees to under 4 in under 8 hours. Rapid chilling halts microbial growth and firms fat, so the next day's cutting blades glide rather than smear. At sunrise, each side enters a cutting carousel guided by laser grids and 3D cameras that map muscle contours in milliseconds. When the algorithm identifies the belly section, stretching from rib 6 down to the hind shank, robotic arms tilt the side under a water-cooled circular knife, separating loin, ribs, and shoulder flanks with surgeon-like accuracy to minimize trim loss. An inspector wearing chainmail gloves palpates the released belly. If fat seams look too thick in one region, the slab is rerouted to become sausage, ensuring every package on the bacon line boasts the coveted even stripes of fat and lean. Qualifying bellies slide into a brine injection chamber the size of a bus. From overhead, a forest of hollow stainless steel needles descends, each drilled with lateral ports so curing solution distributes laterally as well as vertically. The brine formula reads like alchemy. Sea salt for preservation, turbinado sugar for balanced sweetness, sodium nitrite to lock in rose pink color, phosphates for moisture retention, and an herb spice blend. Garlic, white pepper, coriander, sometimes maple or chili, calibrated by the resident flavor chemist. Pump cadence and needle depth change depending on slab thickness so that every cubic centimeter soaks the exact same percentage of brine. To verify, random slabs go to an X-ray densitometer that highlights any injection voids, triggering re-needle passes before the meat is allowed forward. Fully brined slabs stack on rolling carts and wheel into the massager. Think of a horizontal cement mixer turning under vacuum. For 90 minutes, the paddles tumble meat gently, bruising no fiber, yet kneading salt ions deep into myofibrils. Scientists have measured how this exercise unravels protein strands and binds water, ensuring the future bacon releases juiciness instead of shriveling. Once internal salt percentage stabilizes, the slabs rest for up to 12 hours in a refrigerated staging room so flavors equilibrate at a molecular level. To truly appreciate the final flavor locked into every slice, step back to the moment the cured bellies leave their smoking racks and cool on stainless tables that look like airplane wings. At first glance, this cooling corridor seems tranquil, rows of dewy mahogany slabs exhaling faint ribbons of hickory sweet steam. But every cubic meter of air is being choreographed by hidden sensors. Ceiling vents adjust in microbursts, guiding evaporating moisture toward extraction ducts so no single corner develops a humidity pocket that could soften the bark or allow yeast to bloom. A technician jokingly calls it the invisible wind orchestra, yet the data threads it produces are anything but whimsical. Millions of readings per shift feed into the plant's digital twin. A 3D simulation projecting how a 10th degree shift or 5% fan speed change would alter surface water activity 3 hours later. With that foresight, supervisors can weak airflow in real time to coax just the right snap when bacon eventually hits a hot skillet. As the slabs travel onward, another team focuses on the science you can't see at all: the molecular handshake between smoke phenols and muscle proteins. Deep inside a glass-walled lab adjoining the main floor, liquid chromatography vials clink as they're loaded by a robotic arm. Each holds an infinitesimal shaving of bacon, destined for an automated flavor profile. Guaiacol, syringol, and vanillin peaks rise on the screen like neon skyscrapers. When the ratio nudges outside the narrow signature that customers associate with classic bacon, production managers adjust chip moisture or smoke density. Chasing a sensory bullseye, a tweak of maple lactone yields breakfast sweetness. Dial up the mesquite compounds and you have barbecue hero material. What once took artisan smokers weeks of trial and error now happens in a day behind that glass wall, powered by data, patience, and countless micro-taste tests from a panel whose palates are insured like concert pianists' hands. Yet amid the high-tech ballet, there is a moment of pure human ritual that persists. Each afternoon, a bell rings in the corner cafeteria, and line workers gather for what they affectionately call crackle o'clock. A chef with a cast-iron griddle, seasoned by nothing but bacon fat, lays down sample strips from that day's run. Sizzle echoes over chatter, and soon everyone, from the newest hire to the plant manager, tastes and votes. Perfect, almost there, or needs tweak. Laughter mingles with smoke tendrils curling towards ceiling vents, and for a few minutes the pressure of throughput graphs and SPC charts melts into the immediate joy of crisp edges and molten fat. More than any algorithm, this simple practice defends tradition. It reminds everyone that behind gigaton volumes lies a product whose worth is ultimately judged by senses, memories, comfort. After the last crumbs are wiped away, the plant's gears spin back to full speed. Forklifts hum down refrigerated corridors, autonomous carts glide past flash freezers, and pallets vanish through dock doors into trucks already idling at 2 degrees Celsius. Somewhere hundreds of miles away, dawn will break, a refrigerator will open, and a skillet will hiss, unaware that its morning star was finessed by invisible winds, decoded molecules, and the daily crackle that keeps a giant factory's heart unmistakably human. Smoking begins at dawn inside houses that resemble row after row of walk-in safes. Slabs hang from stainless combs, spaced just enough for air and smoke to swirl uniformly. Programmable controllers modulate humidity, temperature, and airspeed in stages. A drying phase at 55 degrees Celsius wicks surface moisture. A coloring phase introduces dense smoke from smoldering hardwood chips, often hickory, apple, cherry, or mesquite, at 65 degrees. Finally, a gentle cook at 78 degrees brings internal temperature to the USDA-mandated 63. Several megaplant smokehouses rely on liquid smoke, atomized into vapor, a filtered condensate capturing wood volatiles without ash particulates, enabling a consistent profile unaffected by ambient barometric swings. Either method yields that signature mahogany sheen and the heady bouquet we associate with weekend brunch. Cooled to below 5 degrees, the slabs undergo hydraulic pressing that flattens minor warps, producing rectangles easy for slicers to index. Vacuum stiffening also firms texture. Slabs are sealed in plastic bags and subjected to minus 90 kilopascal vacuum inside a tumble freezer for 30 minutes, partly chilling, partly compressing tissues so blades will shear, not tear. Slicer halls clang like printing presses. In-feed conveyors straighten each slab toward a guillotine of 20-inch circular blades, serrated like surgical saws and spinning at 300 RPM. Optical sensors measure slab thickness on the fly and reposition servo motors every few milliseconds, so each rasher emerges at exactly 1.5 millimeters, or thinner if a gourmet customer demands shaved bacon. Reject sensors flag any slice that deviates more than 1/10 of a millimeter, flipping it onto a regrind belt bound for bacon bits. Slices land fanned in neat shingled stacks upon polyfilm sheets. Twin robotic arms flip 8 stacks a second into thermoforming molds, where heat and vacuum shape custom trays before top films descend. As the chamber seals, oxygen is evacuated and replaced by a precise mix of carbon dioxide and nitrogen that retards spoilage while leaving flavor intact. A step called modified atmosphere packaging. Inkjet heads spray lot codes in food-grade dye while inline metal detectors and X-ray scanners safeguard against shards, even though earlier magnets captured virtually every needle and blade fragment. Cartoners then drop 10 retail packs into corrugated boxes, and palletizing robots build towers 30 cases high. Within 15 minutes of slicing, bacon is already waiting in a 40-meter-long blast tunnel, driving temperature to 2 degrees. locking texture while the pallet is shrink-wrapped and labeled for cold chain transport. Behind the gleaming machinery stands an army of specialists. Emily, a sensory panelist, starts her shift by frying sample slices in standardized skillets. She records crispness acoustics with a calibrated decibel meter and tastes for balanced salt, sweet, and smoke notes. If volatile compound chromatography later confirms her palate detected a smoldering wood imbalance, the sawdust moisture feed in the smoke generator is adjusted. Ahmed, a maintenance engineer, carries a thermal camera searching for motor bearings trending a few degrees warm, an early warning that unscheduled downtime could derail weekly output targets. Leon, a microbiologist, plates humidity swab samples onto agar each hour, proving that listeria counts stay well below regulatory thresholds. Each roll embodies the hidden craft behind an everyday food. The gigantic volume of byproducts streaming from this facility finds new life rather than landfill. Trimmed fat renders into lard flakes for pie crusts, cracklings for snack brands, and oleochemical feedstock for soap. Bones grind into calcium-rich mineral meal for organic fertilizer. Even wastewater laden with dissolved protein traverses anaerobic digesters generating methane that fires steam boilers, offsetting fossil fuel. That circular economy diminishes the carbon footprint per bacon slice to levels unheard of only a decade ago, a statistic sustainability divisions tout when courting eco-conscious supermarket chains. Culturally, bacon enjoys a fan base as passionate as any pop stars. In the United States, home to more than 2 million tons of yearly output, 70% of households keep at least one pack on hand. Food trucks drizzle bacon jam over burgers. Haute cuisine chefs candy it with brown sugar and cayenne. Dessert parlors crumble it atop maple ice cream. The factory feeds this demand in 97 SKU variations. Thick cut, applewood smoked, center cut, low sodium, maple flavored, uncured nitrite-free, even fully cooked microwave ready. Each SKU spins off a dedicated slicing and packaging program that logs recipe metadata so any recall can pinpoint not just the production day, but the 20-minute window, the farm lot, and the feed batch. As our tour winds down, imagine dawn in an ordinary kitchen. Someone peels open a vacuum pack, arranges pink and white ribbons on a skillet, and listens to the hiss as water flashes to steam, fat cells liquefy, and meat fibers curl into ruffles. That sensory flourish, a sound, a scent, a taste, echoes months of breeding, tons of grain, gigawatts of refrigeration, kilometers of stainless steel, thousands of calibration checks, and the silent choreography of people and programmable logic controllers working in concert. Bacon may look humble, but it is the edible summation of biology, engineering, chemistry, logistics, and a worldwide appetite for a tiny moment of indulgence. So the next time your breakfast plate arrives, shimmering with crispy goodness, pause a heartbeat before the first bite. Behind that single strip lies a 6-month saga. A piglet nourished on tailored diets, a gentle journey through humane handling, a theater of blades and brine and smoke, a ballet of robots slicing fractions of a millimeter, and a refrigerated race across continents. All engineered so that a fleeting crunch and a curl of fragrant vapor can greet the morning. That is the incredible scale, precision, and devotion that define how millions of tons of bacon emerge from the world's biggest factories, destined to delight taste buds, one irresistible bite at a time.